At this time, I hope you enjoyed your meal and you had a wonderful meal. I'd like to introduce you to Amy Scheller. Amy Scheller is going to tell you a little bit about our guest speaker and introduce her.
Friends, I have the distinct honor of introducing our guest speaker tonight, Dr. Laura McBride, Assistant Professor of Chemistry and Biochemistry at Albright College. Laura's academic journey began with a Bachelor's of Science degree in chemistry from Moravian College, where her passion for environmental chemistry and climate change took root. Her commitment to these fields led to significant milestones, including participation as a civil society observer at the United Nations Framework Convention on Climate Change 21st Conference of the Parties, where she witnessed the historic negotiation of the Paris Agreement. Continuing her academic pursuit, Laura earned her PhD in chemistry from the prestigious University of Maryland, College Park, solidifying her expertise in her chosen field. In 2022, she brought her wealth of knowledge and dedication to Albright College, where she currently serves as an assistant professor. Dr. McBride's research interest encompasses crucial areas such as climate modeling, stratospheric ozone depletion, and air quality. Her groundbreaking work has garnered recognition, including a significant $500,000 grant from NASA to support her research on the ozone layer. Beyond her impressive academic achievements, Dr. McBride's journey and accomplishments serve as a role model for young girls interested in pursuing STEM vocations. Her journey is a testament to the possibilities within these fields, inspiring future generations to follow in her footsteps. With her expertise, dedication, and innovative approach to scientific inquiry, Dr. Laura McBride is not only shaping the academic landscape, but also contributing profoundly to our understanding of environmental challenges and their solutions. Please join me in welcoming Dr. Laura McBride to the podium.
Hello, everyone. Thank you all for being here today to celebrate and raise money for the STEM Youth Explorer Academy. This amazing program to educate our young people in STEM cannot happen without your generous support. I also want to thank you all for having me here today. I especially want to thank Rotary International District 7430 for their hard work and dedication to bettering the lives of people living in southeastern Pennsylvania and around the world, Amy Scheller for that wonderful introduction, and Amy and Al Engel for asking me to speak at this event. So I want to spend the time that I have with you talking about how I have gotten to be where I am today, my STEM journey. And I'm going to frame my journey in the context of the STEM Leaky pipeline, which some of you might have heard of. For those of you who have not, the STEM Leaky pipeline refers to the phenomenon of girls and underrepresented students starting out their educational careers interested in STEM, but who drop out along the way. This phenomenon has actually been known for decades. And while we have made improvements over the years in retaining girls and underrepresented students in STEM, there's still work to be done, which is where all of you come into play. Since I can remember, I was always interested in science, math, the environment, and school. As a kid, I would play school with my sister after spending all day at school. Our stuffed animals would be our students, and I was always responsible for teaching math. I never wanted to teach our students reading or English. I always wanted to teach the math, so my sister had to do the reading and English. I joined Girl Scouts in early elementary school, and my troop did a lot of activities that involved science or being outside, and I always enjoyed being a part of those activities. In 5th grade, I joined the environmental club. I liked learning about the environment and doing projects at my elementary school that involved being outdoors. 5th grade is when the Leaky pipeline starts. girls will start to think or be told by a trusted mentor, such as a teacher or a parent, that they are not good at science or math. I was not one of them. In my 6th grade class, it was taught by Mr. Haley, I was introduced to my first research project. I had to come up with a question, a hypothesis, and develop an experiment to test the hypothesis. I do not remember exactly why I chose the question that I did, but I chose, do scented or unscented candles burn longer? And so my mom and I went to the dollar store and we purchased scented and unscented votive candles, and I lit multiple of each type of the candle and then timed how long they stayed lit. I do not remember the results, but I do remember being fascinated with the process of conducting an experiment and collecting data. In 8th grade, my science teacher was Mrs. Eisen. She was the only black teacher that I ever had in K through 12, college, or graduate school. She was also my first female teacher that only taught science. And so she was my first role model, and she showed me that women can be scientists. And I remember on the first day of class, she said that no one ever gets an A in my class. And I thought to myself, we'll see about that. And at one point in the school year, I earned 8 100% in a row on the weekly quizzes. And Mrs. Eisen was convinced I was somehow cheating because no student had ever achieved such good grades in her class. And for the record, I did not cheat. I was just that good. Thank you. Unfortunately, in 8th grade, many girls will think that science subjects are too hard. I was not one of them. During high school, I took environmental science, biology, physics, and chemistry classes. And it was not until my 11th grade chemistry class that I realized I wanted to pursue STEM in college and as a career, specifically chemistry. The ideas and concepts that we learned in chemistry just made sense to me. I loved doing the math and something us chemists call dimensional analysis. I could do dimensional analysis all day. I decided to take AP chemistry in 12th grade and looked at colleges where I could major in chemistry. I feel like my parents were baffled by me. Neither of them are scientists, and neither are any of my other family members. They might have wondered where I came from. Even so, they were supportive of me pursuing chemistry. At the age of 18, the majority of girls think that science, technology, and engineering jobs are for boys. I was not one of them. I chose to attend Moravian College because I loved the historic campus, the students, professors, and the fact that I could skip general chemistry if I earned a 5 on the AP Chem exam, which I did. And so during my time at Moravian, I took many chemistry classes. And in each chemistry class, I was convinced that I would be that type of chemist. So in organic chemistry, I wanted to be an organic chemist. And in analytical chemistry, I wanted to be an analytical chemist. And it was not until I took environmental chemistry as a sophomore that I realized you could have a career in the chemistry of the environment. And I knew during that class that I really wanted to do that. And so according to Yale Scientific, 49.2% of women who originally intend to major in science and engineering switch to a non-STEM major. I was not one of them. At Moravian, I conducted multiple undergraduate research projects with Dr. Diane Husick. The project that I liked the most involved analyzing zinc contamination in plants at the Lehigh Gap Nature Center, which is a Superfund site near Palmerton, Pennsylvania. For those who do not know, a Superfund site is a place that's been so severely contaminated, it will take hundreds of millions to billions of dollars to remediate. So the Environmental Protection Agency and the company responsible for the Superfund site will conduct research in order to best determine how you clean up that site. And so my project involved determining if the zinc contamination that was supposed to be sequestered in the soil was spreading to plants growing at the site. I spent the summer between my junior and senior year climbing the mountain, collecting plant samples to analyze in the lab. I still have fond memories of being on the mountain as the sun was rising to find the samples that I needed. Working with Dr. Husick showed me that I could pursue interdisciplinary science and combine my knowledge and passion for different fields, chemistry and the environment. This research project helped reinforce my interest in environmental chemistry. I also took a climate change class as a junior with Dr. Husick. I found this class captivating. We learned about the science, social, economic, and political aspects of climate change. And I wanted to go to graduate school to become Dr. McBride, and from this class, I realized that I was going to study climate change in graduate school. I specifically wanted to combine chemistry and climate science. And the one part of climate science that intrigued me, and still does to this day, is the fact that carbon dioxide vibrates in a specific region of the electromagnetic spectrum that causes the molecule to absorb heat when it's in the atmosphere. And this property of the molecule is the whole reason why climate change occurs. If carbon dioxide and other greenhouse gases did not do this, then climate change would not be happening. When you get down to it, climate change is caused by simple chemistry. My mind was blown, and I wanted to learn more. I graduated summa cum laude from Moravian College with a bachelor's in chemistry and honors in chemistry and environmental science. According to Yale Scientific, and based on data from 2019, so it is a little old, so many women have dropped out of STEM that less than 40% of STEM bachelor degrees were awarded to women. Of the women that dropped out of STEM, I was not one of them. I decided to attend the University of Maryland, College Park, to pursue a PhD in chemistry under Ross Salowich. My initial research focus was on climate modeling, even though I was in a chemistry program. It is highly unusual for a chemist to do climate modeling research. Most people studying climate science have a physics, earth science, or atmospheric science background. My knowledge of chemistry gives me a unique perspective on climate science that other climatologists do not have. Towards the end of my PhD program, I transitioned into studying atmospheric chemistry and stratospheric ozone depletion due to a grant that we received from the National Aeronautics and Space Administration, or NASA. This research allowed me to use my environmental chemistry knowledge to answer questions. During my 6 years at graduate school, I attended and presented at conferences, published papers, and worked on projects with well-known climate scientists and atmospheric chemists. I enjoyed spending my time deeply involved in research, but my true passion was in teaching. I had the opportunity to teach general chemistry, organic chemistry, and climate change for non-majors. Through these experiences, I realized that I love to teach and help students understand the topics I found interesting. I should not have been surprised. I thought being a teacher was fun as a kid. I wanted to become a chemistry professor at a primarily undergraduate institution. That was the goal. As a professor, I would be able to mentor students in STEM, just like Dr. Husick mentored me. According to the State of Women in Science report, by the time one gets to the end of graduate school, 75% of women who originally intended to pursue STEM have left the discipline. I was not one of them. After earning my PhD in chemistry from the University of Maryland, College Park, I accepted an assistant professor of chemistry and biochemistry position at Albright College to teach environmental chemistry and climate change. At Albright, I have taught general chemistry, environmental chemistry, and introduction to climate change. I have mentored 5 students on independent research projects, published a paper in the journal Science, was a co-author on the 2022 scientific assessment of ozone depletion, published by the World Meteorological Organization, and was awarded a $500,000 grant from NASA. According to the Association for Women in Science, across all higher ed institutions in the US, less than 40% of assistant professors in STEM are women. I am one of them. So why did I make it through the Leaky STEM pipeline when so many of my peers did not? And in reflecting on my journey, there are several key components that stand out. I had several supportive mentors along the way. Dr. Husick was, and still is, a very important mentor. She showed me what it's like to be a female scientist and that I can achieve anything I set my mind to. She became my inspiration to pursue graduate school. Ross helped me grow as a scientist in graduate school and exposed me to many opportunities that other graduate students did not have. I never had anyone tell me that I was not good at or should not pursue science. All my teachers and family were very supportive of the idea of me being a scientist. If someone had said to me along the way that I was not cut out to be a scientist or I was pursuing a boys' discipline, then maybe my trajectory would have looked different. In multiple situations in graduate school, I would be the only woman in the room. This happened during research meetings, classes, and presentations. In the moment, I never realized it. No one made me feel singled out or like I did not belong. If someone had, maybe it would have been different. According to the Harvard Business Review, more than 63% of women in STEM careers reported having to provide more evidence of competence than others to prove themselves. They had to constantly show that they belonged, which weared them down over time and led them to leave STEM. For underrepresented minorities such as Black, Latina, and Asian women, the percentage is much higher. The leaky STEM pipeline is a societal problem. We cannot solve the grand challenges of our time, such as climate change, contagious diseases, and artificial intelligence, without a STEM workforce that includes people from all backgrounds. We need men, women, Black, white, Hispanic, Asian, and others in STEM in order to create innovative and transformative solutions to life's most pressing problems. In 2021, women comprised 51% of the US population, but only 35% of the STEM workforce. Many of these women are concentrated in fields such as healthcare and education. Women and other minorities must be spread throughout STEM fields in order for the world to solve our problems. So in order to fix the leaky STEM pipeline, we need a twofold solution. We need to reduce bias against women and minorities in education and the workforce. Only when we feel that we belong can women and minorities continue in STEM. We also need programs that introduce kids at a young age to science. This is where the STEM Youth Explorer Academy and all of you play an important role in fixing the STEM pipeline. By exposing students at a young age to science and showing them that they belong, we open up a world of possibility to them. Supporting their interests and passions allows a student from a family that does not include scientists, like mine, to imagine themselves to be a scientist. Without programs like these, we will never achieve a STEM workforce that represents the US, is able to compete with other countries at the global scale, or develop solutions to the world's grand challenges. So thank you again for your generosity and support for the STEM Youth Explorer Academy. Without you, we would not be able to make a difference in the lives of our future scientists. Thank you.
Could you tell us the main conclusions about your ozone depletion research?
Yes, I can. So with my ozone depletion research, I've been looking at, is the ozone layer recovering? So many of you probably lived through when the ozone hole was a big thing in popular media, and it's like, we gotta do something about it, and we did. And the ozone hole should be recovering, it should be going away. And what we're seeing right now is not as much recovery as one would expect, given all of the policies that have been put in place. And so what my research shows is that there are some unregulated chemicals that are emitted through human activities, through industry, and through the creation of other chemicals that are leaking into the atmosphere and are depleting ozone. And so in order to have the ozone layer recover and go back to what it should have been before we were emitting CFCs and all of that, there are other chemicals that need to be regulated, but they're currently not. And so one example is dichloromethane, if anyone has heard of that chemical. And if we can regulate those, then we should start to see in the next few years the ozone layer start to recover.
Anyone else? Go for it, Mike.
Do naturally occurring, I'll say, earth events like a volcano or a forest fire, do they contribute to the ozone issue the same as chemical type man-made things?
So they do. Natural events such as volcanic eruptions and large forest fires. So the paper that I published in Science was about the Australian wildfires right before COVID, had an effect on the ozone layer. The natural events tend to be temporary. So a volcanic eruption occurs, and the chemicals that it spews into the atmosphere will only be around for a few months to a couple years. The issue with the chemicals that are emitted by humans is that they're very long-lived. And so once they get up into the stratosphere, they will be there for decades. And so while, yes, natural factors can have an effect on the ozone layer and have had an effect on the ozone layer since the ozone layer was a thing, they only cause maybe a temporary decrease. With human emissions of gases that get up into the stratosphere, that's a decades upon decades long decrease, which isn't supposed to happen. And that's where we run into problems.
Another one over here.
Thank you for your talk. It was great. Is there a correlation between the amount of aircraft that are flying globally, the rates at which they're flying now, as opposed to the turn of the century, on the ozone with all the emissions of aircraft?
That's a really good question. There are some people looking into that because airplanes do fly close to the top of the troposphere. Could any of the chemicals that are emitted from the engines get into the stratosphere? Right now, that's really hard to say, that if that's having an impact. If so, it's not much of one, because the amount of chemicals that an individual airplane would emit is small and would maybe have a very localized impact, but would not have a global one. But it is something to look out for, and I know there are concerns with supersonic jets that would fly through the stratosphere, because they would then be having the chemicals emitted in the ozone layer. And that would be a much bigger problem than being emitted in the troposphere, and then could it even get into the stratosphere is a question. But with supersonic planes, that could be an issue.
Thank you.
I also am a woman in STEM. I also have a chemistry degree from the University of Delaware. I work for a pharmaceutical company currently. I have a young daughter who's 9, who I definitely push to be interested in STEM. What would be your advice for young girls to continue through like you did?
My advice would be, if you like it, to pursue it. And don't let anyone tell you that you shouldn't like it or that you can't do it, because you can. And so you just have to, unfortunately, persevere, but it will create just a life, an amazing career, an amazing life. And so just having that conviction that if that's what you're interested in, to stick with it.
One back here. Watch out, this guy.
How do you convince personalities on television or other political personalities, women, that inadvertently or just cavalierly say, oh, I was never good at math? How do you stop that to make sure that they don't pick up that kind of attitude?
That, such a great question. I'm not sure, because whenever I tell people, they ask me, oh, what do you do? And I go, I'm a chemist. The first thing I get is, I hated chemistry, or I was really bad at chemistry. And I don't know what to say. I'm like, sorry? I love it and was really good at it. Like, I don't know what to tell you. We need to, unfortunately, as women, society teaches us to not necessarily celebrate our accomplishments and to put ourselves down to make others feel better. So to not do that. So even if you didn't feel like you were good at math, you don't have to say it, especially if you're on TV. And the issue is you probably were good at it, you just didn't either have a teacher who supported you or you had someone tell you you weren't good, so then you thought you weren't. And so we just need to change the perception around math and science in general, and instead of saying like I wasn't good at it or I didn't like it, it just maybe it wasn't for me. But that doesn't mean it can't be for you. and to try not to push our perceptions onto others would be my suggestion.
Well, any last question here?
Oh, Lord.
Oh, we got 10 over there.
Are you optimistic about our ability to solve the climate crisis? And if so, what are those things that you're observing that makes that out?
You know, that is a really good question, and every day I have a different view on it because it depends what I read in the news. A lot of time I am optimistic because I'll hear of what young people are doing, and either the legal fights that they're fighting by trying to sue fossil fuel companies or governments into action, or just the inventions they're coming up with in their parents' basements, or the motivation that they have and that they want to address this problem makes me very hopeful for the future. But then seeing every year that our carbon dioxide emissions are increasing and there's just more and more use of fossil fuels is where I get not optimistic. And so it's hard because I think we have the ability to stop it. There's just currently right now not the will. And so once there's the will, there's the way. And I think eventually we will figure it out, but will it be too late for some of us or for some parts of Earth's ecosystem? Because there are species dying, there are habitats going away. And so while Earth will be fine, because I do not like the doom and Earth is going to die, because it won't. It'll be around. It'll be fine. But will, the polar bears be here? Will the tigers be here? Will, things that everyone have come to love be here? And will our lives still be the same? Because the world is changing and we can't keep living it how we have. And so what will our lives look like? That's the big question. So the sooner we do stuff, the better off it'll be. And so I guess my answer is, depends on the day. But there is optimism out there and there are people trying. And so if we can promote their stories, give them funding and help them, then yes, we will solve climate change. And we'll be looking back on it like, wow, do you remember when that was a thing? Just like we're doing now with the ozone layer. That is the most that is the biggest environmental success story of all time. Every single country in the world signed the Montreal Protocol, which was the treaty that banned the production and consumption of the chemicals that destroyed the ozone layer. Every single country in the world. That's the only thing every single country in the world could agree on, was the ozone layer. And so if we can do that with climate change, then yeah, we'll solve it. So we just have to get that will on a global scale.
Didn't she do a fantastic job? I don't know if it's appropriate to talk about Laura's age, so I won't. But she's wise beyond her years.
Thank you.
Very much. You did a great job. Awesome. We are videographing this. We'll post a link, so anybody that paid to be here or didn't, you will have access to the link, and we might do clips of this for the students, as an extracurricular activity. By the way, you just gave a winning four-way test speech. Did you ever hear about that in your school, the four-way test speech contest?
No.
That's how I met your mentor, Karen Campbell. She's a
yes,
Rotarian, she
yes.
was a Western coordinator, and that's how we developed the friendship, and she was so kind to host the first STEM Yay. But anyway, you've done such a great job. You have earned a Paul Harris Fellow. Okay? So I have for you here, maybe you can open this. It won't jump out.
So I have nails, maybe.
Okay. So now Paul Harris is the founder of Rotary, and that's the fellow pin. And
Thank
you can
you.
wear that.
Thank you so much.
And you'll get a certificate or something later on from me to verify that you are that. Now, there's something very interesting about Laura. She's not just a science nerd. She bleeds green. And when we were doing the conversation, I asked her what she did to get her mind off of these serious studies. And she said she's a real big Eagles fan. And she doesn't grade papers now, I have a habit of looking through newspapers while I'm watching the Eagles game, and I tape it just in case I miss a play. But you don't grade papers, you watch the game.
Yes.
So I'm giving you something that you can sit on or lie on or whatever to watch the game. It's a complete football field scale model. So there you go.
Thank you so much.
You didn't have a
Thank
winning
you.
number, but you have a prize.
I won. Thank you.
So now